My name is Brian Alfaro, and my project deals with degree-holding women and their earnings by major. The gender pay gap has been a hot topic in social and political conversations for decades. Data has shown that women make less money than men, though there are a large amount of factors when interpreting the data. Amy Peachy, a columnist for CBSNews.com, wrote an article laying out differences in earnings between men and women with consideration to their earned degrees. With the data given, my goal was to find if there is a discernible difference in earnings for degree-holding men and women. The graduates dataset used for this project was provided by the Corgis Project and Virginia Tech's Department of Computer Science. The data comes from the National Survey of Recent College Graduates. Included is information about employment numbers, major information, demographics, and the earnings of different majors. We are concerned with a few specific pieces of information. Women as share of total describes the ratio of women within a major over the total number of people in that major. Median earnings describes the recorded salary for employed people with a certain degree. Major is the name of the degree major for the graduated students in the study. Rank by median earnings describes the rank of 173 different majors in terms of earnings, with one having the highest median salary and 173 having the lowest. The graduates dataset contains 4 levels of complexity. The women as share of total key is located under the gender dictionary under demographics. The median earnings key is located in the earnings breakdown dictionary under earnings. The major key and rank by median earnings key are located within the major information dictionary. Virtually every dataset will be inhibited by limitations. It may be impossible to capture all facets of data encompassing a perfectly diverse range around a subject. The description of this dataset from the Corgis project expresses that many majors were not available before 2010, so their values have been recorded as 0, with a note that this may affect the average in the data. The data only goes back to 1973. Although women were not employed at the rate they are today, that information before 1973 may still be valid. The data includes only 173 different majors. Many liberal arts degrees are missing from this list. This could have an impact on earnings averages based on gender. Those surveyed are students from institutions within the United States. While I may find this data useful as a U.S. citizen, those viewing this project from another country may not find the information useful. In Amy Peach's article, she wrote, "Even though almost 6 out of 10 bachelor's degrees are awarded to women, college majors that lead to high-paying jobs in fields like engineering tend to be dominated by men." From the given dataset, are Amy's findings apparent? This visualization shows majors ranked by median earnings of a given major on the x-axis, plotted against the ratio of women with that given degree on the y-axis. The majors are ranked in such a way that the value at 1 is the major with the largest median earnings, while the major at the rightmost value of 173 yields the least median earnings. While there is certainly dispersion in the plotted data, it is possible to infer that there is a trend in this graph. That is, it may be assumed that less women happen to graduate with degrees that earn more money. As an item of note, the graduates dataset holds 173 majors. The major ranked with the lowest median earnings is library science. The library science major also has 87.8% of women graduating. The median salary for library science graduates is $22,000. In an effort to better understand the plotted data, we are able to show the ranked major earnings against men's shares of total. This adds to our ability to interpret the data and further visualize the assumption that less women graduate with degrees that have higher median earnings. Again, there is a faint correlation that shows that men have a larger ratio in majors that earn more. Furthermore, we can impose both scatter plots on the same graph. By visualizing both previous scatter plots on the same 2 axes, the assumption that less women graduate with degrees that have higher median earnings is strengthened. We can split the graph into 4 quadrants. Quadrants 2 and 3 show a higher number of red X's representing women's shares of total graduates. In Quadrant 2, when majors earn less money, there seem to be more women graduating from them. In Quadrant 3, the cases where majors earn more money, women's share of total graduates is lower. Now notice Quadrants 1 and 4. Where the blue plus sign represents men's shares of graduates. In higher earning majors, there seem to be more men and less men in lower earning majors. Let's look at one last way to visualize Amy Peachy's claim that college majors that lead to high-paying jobs in fields like engineering tend to be dominated by men. Again, through this bar chart, we can infer the faint existence of a positive correlation between the declining earnings of a major and the decline of women's representation within that major. Within the top 25 highest earning majors, the overall share of women as the total graduates is low as a whole. From the graduates dataset, we find that 18 out of the top 25 highest earning majors are engineering related, and all but one major of the top 25 is STEM related. The gender pay equality issue has many stakeholders that are impacted in different ways. For example, in this project, degree-seeking women, degree programs or program directors, and gender equality interest groups are affected by this issue in data. As a stakeholder, degree-seeking women are the most impacted by this issue. The truths about pay equality may have an effect on a woman's choice on which major to enter and eventually which career to choose. As a conflict, women seeking degrees may not feel welcome in degrees that have low representation of women. As stakeholders, program directors should be concerned with low representation of women. Low representation may mean that program has an innate, unwelcoming atmosphere for women. With degrees as a stepping stone to careers, academic institutions are the first line for creating a better and more equal world for all types of people. Program directors have the ability to present the degree specifically to recruit women. Program directors may be conflicted when promoting an agenda based on gender, while the goal of providing education should be genderless. Finally, gender equality groups such as the American Association of University Women are counted as stakeholders. These organizations exist as a means to combat gender inequality, therefore, the gender pay gap has a direct impact on the organization and its goals. As a conflict, these interest groups have many issues to tackle. While we won't go into it here, there is also data available that indicates the gender pay gap is not as simple as discrimination and is more a result of women's choices in careers or differences in hours spent working between men and women. Gender equality interest groups may have trouble defining the fight or prioritizing it. Thank you for listening to my presentation.